Okay, well, what we have here this evening is a Heathkit Oscilloscope Calibrator, a model ig4505. This is a unit in remarkable shape. Nice paint, no major scratches, good looking faceplate, everything functions. And we've replaced the length of coax cable that used to be on it, replaced it with a BNC connector, so you can go ahead and connect up with coax cables with the BNC ends, or hook it up to your test equipment a whole lot easier. You can interchange a lot of different style of connectors this way, or cables. The unit tests DC voltages. It provides DC voltages out from ground, and then starting at 1 millivolt. It'll provide DC voltages in decade steps up to 100 volts. So in 6 decades, you go from 1 millivolt to 100 volts. At the same time, it will provide frequencies in the way of square waves, and it will take you from a tenth of a second pulse width to a 1 microsecond pulse width, and it'll do that in 6 ranges, but then it extends those ranges by allowing you to divide each range by 2 or by 5. So basically you're multiplying your range setting by whatever the switch setting is. So if I was at 0.1 seconds and I go to the number times 2 position, I now am going to have a 0.2 second waveform period, and which means I'm going to double the I'm going to cut the frequency in half, and I'm going to double the period. So that effectively gives you 18 different ranges that you can work with in frequency. So on top of that, you can provide various voltages out at those frequencies as well, and we'll give you a demonstration of that. So you'll be able to adjust your vertical amplitude, the gain settings in your scope. So when you get to the part of a manual that says please adjust trim pot number A1R2 to provide 5 divisions at 10 millivolts per division, or whatever it tells you to do, you can do that. You can set up your 10 millivolts, well, it'd be 50 millivolts over a 5 division 10 millivolt range, and then you can adjust to it. And if it tells you that you need to adjust your time base for a 10 millisecond or 10 microsecond, say 10 microsecond pulse, and you want to adjust so that you get it to show up on the gradical every step, you can do that as well. Now I've got this oscilloscope calibrator connected to an oscilloscope, and I've also got it connected to this Fluke 8810 5.5 digit DVM, just to kind of give me an idea what's going on. Now, the calibrator was meant for a scope, which if you're lucky, you're going to get you'll be able to get maybe 1 decimal place, possibly 2, but never more than that. With a digital meter, you're going to be able to get much more. So the unit wasn't meant to calibrate digital meters, although it can give you a reasonable approximation of a voltage to allow you to test them to see if they're functioning properly. Just not to calibrate to any great degree a digital meter. But for a scope, not a problem. So what we're going to do, right now we're on the 100 volt range. We've put ourselves in the DC position. Do that with this switch, turn to DC, 100 volt range. And on the scope, I have myself on 5 volts per division, and I have my meter probe on the times 10 position. So whatever comes into my scope is 10 times larger than what the scope actually sees. And there we go. So with 5 volts per division and 2 divisions, that's 10 volts that I have at the scope. So because my probe is dividing what comes in by 10, I must therefore have 10 times as much voltage coming in, and that's 100 volts. So I have 100 volts coming into the scope, and I'm getting two steps on the range switch, and that's perfectly okay. If I was to the maximum I could show without the times 10 position on the probe, if I went to times 1, I have 8 divisions, and I've got 5 volts division. That means I could display 40 volts. So I wouldn't be able to show you 100 volts, but I can by utilizing both the probe and the meter. Now I'm going to take my oscilloscope down to the next range, and the next range is 2 volts per division. And I see that I've jumped up 5 divisions. Now, see if that makes sense. 1, 2, 3, 4, 5 divisions. Times 2 volts, that's 10 volts. So the scope is seeing 10 volts. The probe is in the times 10 position, so therefore whatever's coming in is 10 times greater, so 10 times 10 is 100 volts. So we're still showing 100. That's perfectly great. Let's go ahead and turn the range on the oscilloscope calibrator down now to 10 volts. Okay. I happen to be on the 2 volt range, and if I have 10 volts coming in and I'm dividing by 10, that means the scope sees 1 volt. And I am displaying right now half of a division on a 2 volt per division scale, so that's 1 volt. If I went to a 1 volt scale, I should jump up to the first division, and I did. If I go to the 0.5 volt scale, I should go 2 divisions, and I just did. If I go to the 0.2, I jump up 5 divisions. And if I was to go 0.1, I go 10, but I can't display 10, so I'm at the limit there. Let's go ahead and cut our range down now to 1 volt. And I see that my DVM is displaying 1.004, so we're 1 volt to down in the millivolt range. And there we're off by 4 millivolts. But right now I have 1 volt coming through a divider, and so I'm getting a tenth of a volt on the screen. I'm 0.2 volts per division, and I'm displaying half a division. If I go to 0.1, I go up to a full division. I could go to 50 millivolts and jump up 2 divisions. But I could also take my times 10 off of the probe, and if I was, let's see, if I was in the 0.2 volt per division range on my scope, take the times 10 off, then I jump up 5 divisions. 5 times 0.2 is 1 volt. And I'm in the times 1 position on the probe, so 1 volt times 1 is 1 volt. Okay, let's go ahead and check on the next range. And the next range is 100 millivolts. Okay, if I was 100 millivolts, and I'm on the 100 millivolt range times 1 on my probe, then I'm going to go up 1 division. And I just did. See if I can cut down on my... yeah, that's a little easier to see. If I go to the 50 millivolt per division, I should go 2 divisions. 20 millivolts, I should go 5 divisions. No problem. Let's go to the 10 millivolt setting on the calibrator. I'm on 20 millivolts per division. I'm getting a half a division right now. That would be right. 10 millivolts would be half a 20. But I could go to the 10 millivolt range, and I see I go 1 division, or I could go to the 5 millivolt range, and I get 2 divisions. And I get a little bit of noise here, but that's to be expected. Let's go to the 1 millivolt range. And what I've got here is just something above the grounded last step. So that's ground. And that brings me up about half of the smallest mark on my division there, which would be about right. I've got 5 marks in that first division, so I'm supplying 1 millivolt. That would be half of one of those divisions. So here we go. So that's taken us through all of the ranges. And, oh, by the way, let's go ahead and give her. There we go. I'm on the 20 volt range on the Fluke, and I see that I am feeding in 1 millivolt right now. So I'm measuring a millivolt. I see a millivolt. It said it's providing a millivolt. We did a good job with it. All right, now let's take a look at time base. And in order to do that, I'm go to channel B, and I'm going to hook up from my horizontal time base output here. I'm going to channel B, and let's give ourselves a signal. Here we are at 0.1 seconds per division, which if I was to match that would look something like this. Very hard to see, but I'm getting about 1 division in a cycle. So I'm getting 10 cycles across the screen, but I should get 1 cycle if I go 10 times that. So as you can see, we start the cycle here, we come to the mid, shoot across, and then complete the cycle. So in 10 divisions, we do 1 cycle, and that is what it tells us, is that we've got 0.1 seconds per division. So in 10 divisions, I could I could travel at 10 times that speed and display everything in 1 cycle. So let's go to the 10 milliseconds per division setting. I am on the 10 millisecond per division setting right now on the scope, so I should be able then to see that I have exactly 1 cycle per division, which I do. I'm hitting on the same line all the way across. Okay, so that's accurate. Then if I go 10 times larger, or 10 times faster with my scope, I'm going to cover all 10 divisions in 1 cycle. And that's what I want to see, so let's see if we get it. Okay, we start here, jump up in the middle, and we finish at the right-hand side. 10 divisions, we got 1 cycle. This is exactly what we'd expect for a 10 millisecond position. Let's go ahead and put ourselves on 1 millisecond per division. That's a signal that's 10 times faster, so now we're feeding 10 cycles across the screen again, with 1 cycle displayed in every division. And that's exactly what we'd expect. Okay. If I change the range on my scope up by a factor of 10 in speed, I display one cycle again in 10 divisions. Okay, let's go to the 0.1 millisecond range. That's 10 times higher again in speed. So now we're back to displaying 10 cycles across the screen. And if I jump up by a factor of 10, again I get one cycle in 10 divisions. The reason all this is working is because I have adjusted the horizontal in the scope so that it responds accurately with time. And that's really what this is all about. This unit provides a square wave of exactly known period or frequency, whichever way you want to look at it, and you in turn adjust your scope to match that frequency, and now you're reading accurately. Fastest we could go would be 1 microsecond. And let's go ahead and display that. Here we are. 1 microsecond per division. So we have 10 displayed across the screen. And if I go up, raise my scope speed by a factor of 10 again, kick up my brightness just a little bit. Here we see we start the trace, we jump up, we finish the cycle in 10 divisions. So again, we know the scope is calibrated accurately because we're testing it with this calibrator. So that's how you check your horizontal sweep with this unit. Now, you don't have to have a little unit like this. You could buy yourself a room full of fancier equipment. Do the same thing. There's some voltage calibrators over there. The bottom one is a Fluke AC calibrator. The one on top of it is a DC calibrator that basically does this same thing as this, except a lot more accurately maybe and with more range, but same thing that this first style does here is provide DC voltages accurately to the output that you can calibrate to. These frequency generators right here are digital generators. Basically, this side of the calibrator provides what those do. So in this smaller, less expensive box, you got what you need to calibrate your scope. Okay, so something else that can be done is I can choose a frequency to set myself up on, and I can choose a voltage, and I can measure out of my voltage output, and I am going to get that voltage all right, but I'm going to get it in the form of a pulsed voltage. Let's take a look at that. Right now I'm at 1 millivolt coming out, and we see something going on the screen, but there you go, you can kind of see that. Now if I turn my, if I go from 1 millivolt to 10 millivolts, it's going to become more apparent what's going on. Let's turn up our frequency a little bit. There we go. So right now I'm on 5 millivolts per division. I've got 2 divisions, and I've got a square wave coming in at 0.1 milliseconds. Yeah, let's go to 1 millisecond. Alright, there we're 1 millisecond per division on the scope, and I've got 1 millisecond pulses coming in, so I'm going to see a pulse every division, and I do. And I'm coming in at 10 millivolts, On a 5 millivolt vertical range, I've got 2 divisions, and that's 10 millivolts. So I've got a 10 millivolt pulse at 1,000 hertz coming in. Now, what if I go and I say, well, let's have 100 millivolts. All right, I'm going to need to double my. I'm going to need to change my range so I can see it all. But let's go ahead and turn it. All right, I am now on 20 millivolts per division. I have 100 millivolts pulses coming in. So it's 20 millivolts per division. I got 1, 2, 3, 4, 5 divisions. Times 20 is 100 millivolts, and that's exactly what I have in. And at 1,000 hertz. And so on. I mean, that's the way this is going to go. I'm going to play this out here. I can go up another decade. And right now I am I'm reading on my scope. I'm coming in at 0.2 volts per division. I have 5 divisions, so that's 1 volt that I'm displaying on the screen, and I have 1 volt selected on the selector. So yes, I'm reading a 1 volt 1,000 hertz pulse. So there you go. I mean, I can provide calibrated pulses at whatever frequency, at various frequencies here within my range. So it's a very handy little unit for checking just about any range that you need to set on your scope. And as you can see, it's working quite well. So thank you for listening. Happy bidding. And oh, I forgot. Comes with an original Heathkit manual. Don't see too many of these. Manual takes you through the construction of the unit, and then also provides you with a fold-out schematic diagram. And takes you through the calibration, the theory of operation, typical usage. Gives you a troubleshooting chart if you were to ever have a problem. And then you get the board layouts. So, excellent little manual, excellent little unit. Happy bidding. Thank you for listening.